All right, welcome everybody. Looks like everything's set. Okay, welcome. My allergies are acting up, so you'll have to forgive me if I'm a little congested today. Um, if I'm not speaking quite as clearly, or if I have to stop and get a drink. I'm a very sore throat today, and I believe it's because of allergies. So we're moving ahead. I want to spend some more time talking about ratios, percents, these kinds of problems. The problems oftentimes can seem very simple, and if you know how to do them, they are kind of simple, right? That doesn't mean easy, it just means simple, like that there's only a couple of steps that you generally have to do. But a couple of words or even a word different can change the entire meaning of the problem. And I see students struggle with this. Even just now, as I was looking through some of the problems that I want to go over today, I made a couple mistakes. Why? Because I wasn't reading close enough, right? I'm trying to rush through it and get ready for class and just remind myself the kind of problems I'm going to be going over, and I'm rushing through, not reading well enough, right? Not reading the problem, taking my time to really read it carefully, and I ended up missing a couple. It wasn't that I didn't know how to do it, it was that I just wasn't taking my time and being careful, which is a pitfall in this section, because a lot of times the problems are so short, students look at it and assume, oh, I know what this problem is. I did one like it before. And then just like I did before class, you go through and do it, and then you get it wrong and you realize, oh, I should have just taken my time, read the problem carefully, done it right the first time. Then I could have moved on, because it's tricky. Like I say, a couple of words different can mean a very different thing in these problems. So before we get to that, is there any questions? Does anybody have anything they want to ask me? Anyone concerned or confused? Oh, and there was a question about formulas, and I kind of covered it last time. So someone pointed out, I think that video got deleted when I did some cleaning up of the channel. So that video's not on there, but we did cover that. I believe last time or the time before that, we covered manipulating the formulas, and I did a number of examples. So if you're still confused about the formulas and how to solve those, please see me in office hours, and then I can figure out exactly which ones you're working on and having trouble with, and then we can move forward with those. Okay? I was planning to go over some, but I think it might be better. Our time might be better spent on percents and stuff today. So if you're stuck with formulas, come see me in office hours. We'll talk about it. All right? Okay, so ratios, percents, and proportions. So remember, there's a ton of these. There's a ton of these kind of problems that can come up. They're all basically using the same basic math, but like I say, there's a bunch of different ways that these can be presented. So what you need to understand is conceptually understand the mathematics that we're talking about. You can't memorize all of these, right? As you'll see in a minute, the number of different types of problems you have from the homework, there's a bunch of different types of problems. I don't even have time to go over all of them. Even if we had a full class period, like the 5 hours that we would normally be meeting on ground, there isn't time to go over them. So the key to this section is understand the underlying concepts and formulas, and then apply those when you need to. Okay, and remember, one of that one's when in doubt, when you're dealing with percents. Oops. When in doubt, when you're dealing with percents, amount equals base times percent. That equation is going to get you through at least half the time, probably more. So you can fall back on that, see if that works, see if that makes sense. So let's take a look at this problem here. So triangle GHI is similar to triangle JKL. Find the measure of the side JK, round your answer to the nearest tenth if necessary. So what does this mean? What does this mean when they say the triangles are similar? It means they have the same basic shape. And what that means to us, the key that we want to use, is the fact that the ratios of the sides is constant. So see how this side right here is kind of the corresponding to this side? It's kind of like the height. If this was a flagpole or something, that would be the pole going up in both of these triangles. What it's saying is the ratio from 7 to 33 is the same as the ratio of 4 to whatever this side is on the bottom. So if we compare the sides, the ratio of these bottom sides should be the ratio of these side sides. Okay, they match up. So what you're going to do is you're going to make that proportion that we've been seeing in class, where you have an equal sign, you have a fraction on both sides, and then you solve it. So, well, we want to figure out this JK side, right? But we don't have any, we don't have a number here. That's what we're trying to solve. So you just pick a variable, X or A or whatever you want to do. That becomes your variable right there. So we need to remember the ratio 7 to 33. So let's go back to our problem here. Seven over 33 equals, and then we're going to have another fraction over here, but we have to get stuff in the right order. So you have to be consistent. If this 7 is in the numerator of your fraction and this one's in the denominator, then that means your other fraction should be the same, where this number's in the numerator and this thing down here will be in the denominator. You have to stay consistent. If you mix them up, it's going to come out wrong, because otherwise your ratio would be backwards. So 7 to 33 is the same as 4 to x. So then we're going to have 4 for x. Okay, so there's our ratio to set this up. We looked at these last time. So basically what I'm going to do is multiply both sides by 33x, because I want these denominators to cancel. So if I do that on the left side's the easier one. I'm going to get 7x equals, and then what is this? 33 times 4, is that 100? I think it's 132, but let me just double check. 33 times 4, yeah, 132. Okay, 132. Okay, so what did I do? So the step 1 was setting up the proportion. All we did was compare sides and stay consistent. So 7 over 33 equals 4 over x. So I wanted to get rid of the denominators, so we multiplied everything by 7x. By 33x. That got the denominators to cancel, leaving me with 7x equals 132. Okay, now we just divide by 7. And I don't know what that is when you divide by 7. So we get x equals. Did I do this right? It's coming out kind of weird. Let me double check. 33 times 4. 132 divided by 7 equals. Do they want a fraction? Let's see. Oh, round your answer to the nearest tenth if necessary. So that means we're going to get it to 18. So the answer comes out as 18.857. I'm going to round it to 18.9. Okay, I got it. Okay, so the answer was 18.857. They say round to the nearest tenth. I rounded to 18.9, and that was the correct answer here. So you're just setting it up. See how they've got IG on the numerator. That's this left one. And then over here, GH, that's the left one on the big triangle. And we're just doing it in the right order. Go through, get this, which is about 18.9. Then you answer your question. Okay. Okay. There's actually, they show you another method. There's a couple of ways to set up these ratios. You just have to be consistent when you do it. If you're just randomly putting pieces into the proportions, it's not going to work. But fortunately, there's more than one way in which it will work correctly. Okay, so that's the similar figures that you're looking at. That's how we take similar figures and we solve for sides that way. we get? Let's see. Is this the one I want? Basically the same problem. That's not what I want. 456 is what percent of 600? So remember, these are the ones where we use the amount equals base times percent. So here the real question is, obviously the thing we're missing is the percent because they're asking what percent. Okay, actually, hold on one second. I have to get a tissue. Okay, sorry about that. Oh, and the interesting. Okay, so here's where we're going to use that amount equals base times percent. So the only thing you have to figure out when you're doing this problem, which of those numbers is the base and which is the amount. So remember, the base is like the whole thing, right? Like whatever the amount is that you're talking about, like the whole, that's going to be your base. The amount is the thing that is some percent of the base. So by looking at these two numbers, you want to ask yourself, is 456 the base or the amount? And is 600 the base or the amount? We need to know which one it is. So if they're saying 456 is what percent of 600, then hopefully you recognize that 600 is our base. So 600 is our base. So let's start plugging that in. We'll go back up here. So I take this same fraction, oops, right here, and I'm going to plug in. Our amount was 456 equals the base times, so the base was 600, I believe, and then we have some percent that we're left with, right? I'll just call that P for now for percent. And now you're going to do your division. So 456 divided by 600 right? You can either do that division by hand or throw it in a calculator. 456 divided by 600 equals 0.76 or 76%. So P equals 0.76, which is the same as saying 76%. Okay? So 76% should be our answer. Oh, let me put a line break here. So let's go back and see what percent. 76. Hit submit. Should be right. There we go. Okay, now here's the thing. You can catch a lot of your mistakes by just thinking about this a little bit. I find this is one of those sections where people go, oh, percents are too confusing. You need a calculator for that. And they just blindly trust whatever the calculator tells them, and they move ahead. And they don't ever question anything. So there's lots of ways this problem could go wrong. You could press the wrong button on your calculator, which seems silly, but you'd be surprised how often I see people, or I myself, am adding things on a calculator or doing some calculations, and you push the button, but you don't push it quite hard enough, and it doesn't come out right. So you feel like you press it. You got that tactile feedback that you push the button, but you didn't push it all the way. Or students enter the problems backwards. They mix up the base and the percent. Just look at your answer and ask yourself if it makes sense, right? The easiest thing to do is ask yourself, should this be over or under 100%? If you can catch that a lot of the time, that'll fix your issues, some of your issues right there. So 456 over 600 written as a fraction. Should that be bigger than 1 or less than 1? Well, 456 over 600, that should be a number less than 1. So if we think about our percentages written as decimals, those should be numbers less than 1. So this makes sense in this case. 0.76, 76%, that makes sense that we got a number less than 1. If this number over here had been bigger than 600, then our percent should be over 100%, right? Meaning this number should be bigger than 1. So there's a little bit of common sense you can throw in there that will help you catch mistakes before you move ahead with them, right? Before you're having any kind of issues there. Okay? No questions yet? People are following along. All right, let's try percent of a whole word problems. So a bakery sold, and I think I did some of these last time, but I know it takes a few tries for people to get it. And this is some of that stuff that many of you will be seeing in statistics in the future and classes like that. So you want to be comfortable with percents. In statistics, statistics is now our #1 course. That is our transfer level course. So a decent percentage of you are probably going to end up taking statistics as your transfer level math course, right? That's the one where they go, oh, you took statistics, good, that's all you need for your degree. That's the case for a lot of degrees now. But that class is full of percents, right? So you really want to be comfortable with percents by the time they get there. By the time you get there. Let's see. A bakery sold 48 chocolate cupcakes in a day, which was 12% of the total number of cupcakes sold that day. How many total cupcakes did the bakery sell? So you think about this in terms of amount equals base times percent. Oops, darn it, what did I do? I think I hit another button on my mouse and I think it went backwards. So let me see if I can get back there. Okay, here we go. A bakery sold 48 chocolate cupcakes in a day, which was 12% of the total number of cupcakes sold that day. So it's telling me 12% is equal to 48 cupcakes. That makes me think 48 cupcakes is my amount. How many total cupcakes did the bakery sell? Oh, total cupcakes. That makes me think of base. So the thing we're trying to figure out is the base. Okay, so we just go back to that same problem. I mean, to the same formula at least. So amount equals base times percent. We know the percent is 12%, but we don't write it as 12, right? We write that as 0.12. 0.12, so there's our percent. And the amount we said was what, 48? 48. See, it's a pretty simple formula, and as long as you put things in the right space, you're pretty much good to go. Okay, 48 equals base times 0.12. So then to solve this, we're going to end up with what? Let's see. So we've got 48 divided by 0.12. Again, I don't mind if you use a calculator on these, but you should know how to do it by hand. You should remember from your pre-algebra class how to multiply and divide decimals and stuff like that. If you don't, go remind yourself, but I don't expect all of you to do these. But you want to have a basic, I don't expect you to do all of these by hand. So, but you do want to have a basic understanding of decimals and how those work. Oops, I just put this on the wrong line. So 48 divided by 0.12 is 400. Right, so this should come out to 400. 48 divided by 0.12 should be 400. And there we go. This is a slightly different setup of that problem. Notice how they just write it as percent over 100. This is the same equation we're talking about. It's just a slightly different setup for it. Okay. All right. Let's see, where are we? Let's see, we did a percent. Did we do percent more or less? Catherine was out at a restaurant for dinner when the bill came. She wanted to leave a tip of 26%. What number should she multiply the cost of the meal by to find the total plus tip in one step? Now, a problem like this has a number of different ways to go about solving it, right? I talked about this last time, that these types of problems, especially if they're round numbers like 10, 15, 20, 25%, they're actually quite easy to, you can do a lot of them in your head just by thinking about, well what's 10%, and then working from there. There's also a method where you can just go through and calculate it by hand. Here they want you to do it in one step. So I'm going to show you a couple different ways, and I'm going to show you also how to do it in one step like they're asking you to do. So let's see, what do we want? Catherine was out at a dinner. She wanted to leave a 26% tip. What should she multiply by? Well, here's one way of thinking about the problem that takes more than one step. So let's do this. $26% of the bill would, well, what would we do if we wanted to figure out 26% of the bill? We would multiply by what? 0.26. If I multiply by 0.26, that gives me 26% of the bill. That's the tip. So then if, what is the question asked? What number should she multiply the cost by of the meal to find the total plus tip? So we just found the tip, but we're asked to find the total plus tip. This is why you don't want to do math where you're just memorizing things. You want to do math where you're thinking your way through. These types of problems are impossible if you're trying to memorize. If you think your way through, you go, okay, I just found the tip by multiplying by 0.26. So if I want the tip plus the bill, then what do I have to do? I have to add whatever number we get by multiplying by 0.26 to the original bill. The original bill is 100%, right? So we basically have 1 plus 0.26. So we kind of did it in two steps, but they're saying you can do it in one step by just multiplying by 1.26. The 1 represents, I'm not showing it. Sorry, I wasn't showing it on screen there. You can always let me know if I'm not showing the right screen. The bill is 100%. That's 1. 1 is 100%, right? So the bill, that's this first number, the original bill for the food plus 26% for the tip equals 1.26. So the number we should multiply here to do it in one step is 1.26. Now, what I'll say is, don't worry too much about doing it in one step. It's nice when you get comfortable with the one step, but if you get confused and you have to stop and think your way through it and go, well, okay, I can calculate the tip. And then once I have the tip calculated, I could add that to the bill, and that would give me the total of the bill plus the tip. Both are totally legitimate ways of doing this problem, and probably you should be able to do both of them. You should be able to do it both ways, okay? So don't just memorize it. Because here they asked for the total plus tip. What if they had just asked for the tip? Then we'd just be multiplying by 0.26, right? So it depends on how the question is being asked. All right, let's find a word problem here. Levi invests money in an account paying a simple interest of 8.7% per year. Good luck finding something like that now. If he invests $70 and no money will be added or removed from the investment, how much will he have in 1 year in dollars and cents? So let's work through this and let's think about it. So it's $70, 8.7%. Okay. So let's do it this way. So $70 and 8.7%. Is that right? $70, 8.7%. Okay. So let's do this both ways. One where you do it in 2 steps, one where you do it in 1 step. One's not better than the other. One's quicker, but if you've just memorized the quick way and you don't understand it, then you should do it the 2-step way that you understand. Right? You should always do mathematics in ways you understand, or you're going to make lots of mistakes. So think, okay, what's the interest then? Because we want to add that to the original $70. So let's take, my calculation will be $70 times, now what's the decimal that represents my percent? It's going to be 0.087, right? 0.87 would be 87%. 0.087 is 8.7%. So if I calculate this, I get 6.09. So I get 6.09. Now we want to stop and ask ourselves, wait, what did I just calculate? Right? This is a good thing to be doing. Don't just plow ahead multiplying and dividing and stuff. Always ask yourself, wait, what is that 6.09? Do I even understand what I'm doing? The 6.09 is the interest that this individual earned on their account. Okay, but did they ask me for interest? Let's go back and look. Let's see. How much will he have in 1 year in dollars and cents? So no money will be added or removed. How much will there be in 1 year? Well, there's going to be the original money that was invested, and then there's also going to be this new amount of interest, right? So that means that we're not done. We just found the interest. What do? I add that to the original amount now. So my original amount of 70 plus 6.09 will equal $76.09. So 76.09 should be our answer, 76.09. And there we go, we got it. Okay? Okay, so that's one way to answer it. The other way to answer it, notice, so that's method number 1, thinking your way through it. The second way can be thinking your way through it, but I find that students, since it's 1 step, it's a little harder to see what's actually going on. If you're going to use it, make sure you understand it. Method 2 would be to take 70 and multiply by 1.087. Why is that? Because that 1 captures the original $70. Right? So if I do that, I should get the same amount if I didn't mess up. 70 times 1.087. Yep, 76.09 equals 76.09. Right, there we go. So 2 different ways. Up here I took 2 steps. This one took 1 step. You should use the one you understand. And hopefully try to understand them both. But don't just memorize, because otherwise you go, oh, I always have to put a 1 in front. Not always. It depends on what's being asked. So just understand your way through it. Now, why does this work? Let's take a look at this. If we look at the last thing we have written there, right, this 70 times 1.087. Well, what is that? What's really going on there? Well, we've got 70 times 1.087 could be written as 1 plus 0.087, right? Right? So what do we get when we multiply this in? We get 70 equals 70 plus 6.09. Right? So you can see 70 plus 6.09, that's just our calculation up here. So it was really that we took care of in one step when we do it this way, what took us 2 steps up here. Okay. Any questions on any of those so far? It's making sense? All right, be sure to ask if you have questions. Otherwise, I'll just keep picking ones and going over them. Let's see, what was the one we just did? Find percent increase or decrease. Now, they will throw increase and decreases at you. So make sure you're reading carefully. I did one earlier where like I wasn't paying attention and then it's a decrease problem. Okay. Doesn't really change the problem much, but you have to kind of pay attention to what you're looking at. So 1 year, the population of a city was 160,000. Several years later, it was 140,800. Find the percent decrease. So if you think about it as a percent decrease, we should just be able to take 160,000 and the percent, let's see, should be a 13.6%. Forget which way they want. There we go. Sorry. So here's the reasoning behind that. So 1 year, the population was a city with 160,000. Several years later, it was 140,800. Find the percent decrease. So what you do, you take the population and then the other population, and what you do is you get this as 88%. Well, when it had 160,000 people, that was 100% of the population, right? So when it's at 140,800, it's at 88% of that total population. That means it decreased by 12% in order for us to get there. That makes sense? Right? But you have to read carefully. You have to read carefully because sometimes it's going to be an increase problem. Let's do this one, percent more or less formula. What is the result when a number 94 is increased by 50%? This is just right back to those formulas that we looked at. The amount equals, amount equals base times percent. You're going to bring out those ones. So these ones that say formula, that's what you're going to be bringing out as those problems. Let's do this one. Ian went shopping for a new camera because of a sale. The store was offering a 45% discount. If the price of the tag was P, which expression represents the price after the discount but before tax? Okay, so that was a lot of information, right? I didn't even catch everything on there the first time. So you be careful, be willing to read these problems a couple times. Let's see. The store was offering a 45% discount. If the price on the tag P, so we know what P is. They're telling us in the problem. That's the price on the tag, okay? Which expression represents the price after the discount but before tax? Okay, so we're not considering tax here. We're considering just what the base price of the camera is going to be after we take the 45% discount, okay? So Here's where we have to be careful, right? 45p, that's not right because 45% should be written as 0.45, right? So that one's easily out. This is a technique that you should use. This isn't necessarily just math. This is test-taking skills. One of the things you can do on a problem is eliminate the answers that you know are clearly wrong, and then you narrow it down to the ones that at least have the possibility of being correct. 45p doesn't make any sense because 45 is not written as a decimal there. That's no good. So this option's out. 0.955p. I know that doesn't make any kind of sense. Let's get rid of that one. So these first two on the left, oh, you can't quite see them. These first two on the left, those are out. We know those are wrong. So now we can narrow things down to these two on the right. 0.45p and 0.55p. Now we have to be careful. A lot of people are going to jump immediately to 0.45p and say, well, it says 45% in the problem, so change that to a decimal. It's 0.45, right? I don't think so. Let's read again. The store was offering a 45% discount. So discount means they're reducing the cost of the price by 45%, right? You're not paying, your price is not now 45% of the original. It's 45% less than the original. So the 45% is the discount. That's what's being reduced. You don't have to pay that amount. That's the reduction. Well, if 0.45 is the reduction, then that means you're left with 0.55. See? Does everyone see that? I know that's one that throws people off because they go, but it said 45 in the problem, so why isn't it 0.45? It's because that's your discount that you're subtracting off is 0.45p, leaving you with 0.55p in the problem. All right. Speak up if that's confusing. Otherwise, I'll assume that people followed along perfectly fine and understood what I was talking about. That's another reason you got to read carefully. All right, what do we have? What is the result when the number 28 is decreased by 2.6%? So again, you got to think your way through this. Let's see. If I'm going to decrease by 2.6%, I have to first figure out what 2.6% is and then subtract that from 28. So there's two steps here. It doesn't tell you those steps. You have to be able to think through those steps and make sense of them. Let's see. Here's another one with how you would write it algebraically. The value of x is decreased by 6%. Which expression represents this situation? Okay, decreased by 6%. Okay. Well, if we're decreasing it, it should be less than 1 as far as the number. So this 6x is probably out. All right, but think about the problem we just did. If I decrease something by 6%, what percent remains? Well, if I have $100 and you take away $6, that's 6% of 100, I'm left with $94. So I'm actually left with 0.94x of the amount. See, you have to be careful about that. Don't just automatically look for the number that appears in the problem because they're going to mix up the wording and ask you basically for the leftover, the piece that still remains. And I know that definitely throws people off. Let's see. Yeah, let's do this one. Okay, let's take a look. Aiden bought a pair of sunglasses online for $55. He used a coupon code to get 40% discount. The website also applied a 10% processing fee to the price after the discount. How much was the processing fee? Round to the nearest cent. Okay, so what we're going to want to do here is go in the right order and apply things in the correct order. They're specifically telling us the website applied a 10% processing fee after the discount was taken. So we want to take the discount calculation first, followed by the processing fee calculation, and then get our final answer. Okay? And they want us to round to the nearest cent. So what do we have? We have $55, then 40 and 10 discounts. Okay, so let's find that. $55, 40% discount, followed by a 10% discount. Okay, so I just jotted these things down to remind myself so I don't have to keep flipping back. But let's think about that. Was that right? $55, 40%. Okay, so let's figure out first what was the cost after the discount. So if we have $55 times 0.4, right? 40%. So that really is 55 times 0.40. If you want to write that last zero on there, you can. So 55 times 0.4 is 22. Now that's the discount. That's not the new price. That's the discount. This is a very common thing I see when students do this wrong. It's because they just assume that whatever they calculated was the answer to the question rather than stopping and thinking, oh, it's relevant, but it's not the answer to the question. So 22 is the discount. So then we take 55 minus 22 equals 33. So that means after Aiden's discount, the base price should be $33 for the sunglasses, right? Okay. But now we're going to take a 10% discount on that. So let's figure out what 10% of that would be. So we can do that one in our heads, right? Hopefully you just move the decimal place. 10% of 33 is 3.3. So 33 minus 3.3 is going to be what? 29.7. So the price should be $29.7. Now I didn't use anything fancy there. All I did was I just reasoned my way through the problem, just thinking my way through and using percents when I'm supposed to use percents there. So let's see. Oh, wait, what did I do? Okay, what did I do? 30, 40%, 10%, 55. Oh, you know what I did? I didn't answer the right question. I did what I was just talking about. See how easy it is to do? I forgot what the original question was, and I answered the wrong thing. They're asking, what is the processing fee? Well, the processing fee was this $3.3. See how all my work was correct, but I got the answer wrong because I didn't reread the question? It's a bummer when people lose points on a test like that where I see that, oh, look at all this work you did correctly, but you answered the question wrong. And you just saw me do it. So it's easy enough to do. Okay. So, okay, I think we're good with that stuff. If you need help with any of these problems, including the formulas or percents or ratios or any of that, please come see me in office hours, and I can help you out with that. We'll take care of it and get it ready to go, get you all ready to go. Otherwise, I will see you in a couple days. Thanks, everybody. Feel free to stick around in Zoom, or if you're on YouTube, switch over to Zoom and ask me any questions that you want, and I'll help you with any kind of concerns or anything. Okay, thanks.